Welcome everyone to this explainer. Today, we're going to look at the computer not just as, a cold box of wires and plastic, but as a truly fascinating anatomical system. Think of it like an intricate, functional body, one that actually translates our human intent into digital action. We are taking a journey into the very heart of the machines that power our modern world, and I'm absolutely thrilled to break it all down for you. To get us there, here is a quick roadmap of what we'll be covering today. First, the anatomy of computing. Then, the great divide between input and output. After that, capturing our world, displaying the results, and finally, caring for your ecosystem. All right, let's jump right into section 1, the anatomy of computing, and take a look at the big picture. At its absolute core, what actually is a computer? Well, it's an electronic device that operates on a continuous logical loop. It accepts data, which we call input. It then processes that data, stores it, and ultimately spits out meaningful information, the output. The cool thing is, it doesn't just hold information, it transforms it. It's a highly active decision-making tool. When we peek inside the tower, it's wild how much the anatomy perfectly mirrors our own. The CPU, that acts as the undeniable brain, processing every single impulse. But just like us, a brain can't work alone. It relies on the motherboard to act as its central nervous system, connecting all these internal organs together. You've got the RAM acting as short-term memory, the hard disk or SSD serving as long-term storage, and of course the power supply. That's essentially the beating heart, pumping electricity to all these vital parts. Moving right along to section 2, input versus output, the great divide. So there is this fundamental divide in how we actually interact with these machines. On one side, we have input devices. Think of these as the machine's senses. They translate our human actions into data. On the flip side, we have output devices. These give us the results produced by the computer, translating data back into a form that we humans can actually understand. It forms a complete conversational loop, right? Input goes in, output comes out. And both sides are absolutely necessary for a computer to do its job. The absolute classic example of this conversational loop is the keyboard and monitor pairing. The keyboard acts as our primary human-to-machine translator. It is packed with typing keys, function keys, and navigation keys to let us speak directly to the computer. And right next to it, the monitor. That's the essential machine-to-human visual display unit. Without this pairing, the conversation between you and the digital world simply wouldn't exist. Okay, section 3, capturing our world. Let's see how we translate our physical space into digital space. Have you ever actually stopped to think about the micro-narrative happening every single time you move your hand? When you physically slide your mouse across a desk, a tiny sensor or light on the bottom detects that exact physical movement. It immediately converts that movement into electrical signals, firing them rapidly over to the computer. The computer processes those signals, and in a fraction of a second, the pointer on your screen moves in the exact same direction. It is a seamless translation from physical space right into digital space. Now, what about the computer's eyes? That's where the scanner comes in. When you place a physical document face down on the document glass, a highly precise light source illuminates the page. Then, the scanner head, which contains an image sensor like a CCD or CIS, captures that reflected light. It literally reads the light and dark spaces of your physical paper, converts them into digital data, and sends it straight to the computer via a USB cable. Just like that, a piece of paper becomes a soft copy that you can edit, save, or email across the globe. And what about the computer's ears? Well, that brings us to the microphone. When we speak, we're pushing physical sound waves through the air. These waves travel into the microphone head and hit a super thin membrane called a diaphragm, causing it to physically vibrate. The internal components of the mic then take those mechanical vibrations and convert them into an electrical signal. The signal gets sent straight to the computer, which can then process, record, or instantly broadcast our voice anywhere. Pretty cool, right? Section 4, displaying the results. Now let's flip the script and see how the machine talks back to us. Let's circle back to the monitor for a second and look at its incredible evolution. We started with CRT monitors. Remember those? Massive, bulky boxes that consumed a ton of electricity and frankly gave you a free arm workout just trying to move them. Then, thankfully, we advanced to LCD monitors using liquid crystal technology to make things thin and light. That quickly evolved into LED monitors, which gave us way better brightness and energy efficiency. And today, we have OLED monitors. These use organic light-emitting diodes to offer the absolute best picture quality, contrast, and colors money can buy. But what if you need a permanent physical record of your work, a hard copy? Well, that's the printer's job. The computer sends the digital data, the printer processes it, and then components like a print head or toner powder go to work directly on the paper. The technology here is super diverse. You've got older dot matrix printers, which literally use tiny pins to strike an inked ribbon. They're incredibly noisy, but still used for things like carbon copy billing forms. Then you've got your everyday inkjet printers, spraying microscopic droplets of ink, and high-speed laser printers that use advanced lasers and toner to literally bake the text right onto the page. And just as the computer listens through a microphone, it speaks to us through a speaker. This is basically the exact reverse process of capturing sound. The computer generates an electrical audio signal. That signal travels to the speaker, but usually it's way too weak for us to hear, so an internal amplifier boosts it up. This boosted signal then hits the speaker driver, forcing it to physically vibrate. Those vibrations push the air, creating the sound waves that hit our ears. From electrical data to physical sound, all happening in mere milliseconds. Finally, for output, we've got the projector. This is the ultimate output device for taking the computer's results and sharing them with a whole room. It takes the digital input, shines an incredibly bright light source through a lens, focuses it, and blasts that image onto a massive screen or wall. Whether you're in a classroom or a movie theater, the projector takes a private digital space and turns it into a shared, public experience. Section 5. Caring for your ecosystem. Time for some quick, practical maintenance. Just like a biological body, this delicate digital ecosystem needs proper care from us to survive. You absolutely must keep components clean and dust-free. Dust can suffocate the sensors and cause the internal organs to overheat. Also, never pull wires forcefully. Remember, these are the delicate nerve endings connecting the entire system. Keep everything far, far away from water and moisture. Electricity and liquids are a guaranteed disaster. Handle everything with care, and maybe most importantly, turn the computer off when you aren't using it. Give the machine a chance to rest. Following these basic rules ensures a long, healthy life for your tech. So we've explored the incredible anatomy of today's computing, all the way from the tactile clicks of a mouse to the stunning pixels of an OLED screen. But I want to leave you with this final provocative thought. As input and output devices continue to evolve at lightning speed, what does the future interface actually look like? In a couple of decades, will we even need physical keyboards or glass monitors, or will the brain of the computer bypass our hands and eyes entirely and just connect directly to ours? It definitely leaves you wondering. Thank you so much for joining me on this explainer, and keep questioning the technology that shapes our world.